Part A. Express 3x squared minus 4x over x squared times 3x minus 2 in partial fractions. So I'm going to first write a over x plus b over x squared. So that deals with the fact that we've got the x squared there. You need the a over x and you need the b over x squared. You need both of those. And then we need the c over 3x minus 2. Right, now, if I were to get a common denominator now, let's have a look. I would, with the a term, I've already got an x, so I've got one of those x's. So I would need another x to get the x squared. And I would need the 3x minus 2 as well. Now looking at the b term, I've got the x squared, so I've got that. So all I need is the 3x minus 2. And now looking at the c term, I've got the 3x minus 2, so I need the x squared. Right, that will give me my common denominator. Now I have got the same on the same denominator on each of these fractions, which means that my numerator here would have to equal the numerator here. So down here I'm going to rewrite 3x squared minus 4 equals ax times 3x minus 2 plus b times 3x minus 2 plus cx squared. To work out each of these terms, I'm first going to let x equal 0. The reason I'm choosing that is it's going to make this term here become 0, so I don't need to worry about this. It's going to make this term here become 0, so I don't have to worry about this. And it will allow me to work out the b. So, substituting 0 in. On the left-hand side, 3 times 0 squared minus 4 is minus 4. On the right-hand side, like I said, the a term and the c term will disappear. And I'll get b multiplied by 3 times 0 minus 2, which is minus 2. So this is telling me that b equals 2. Minus 4 divided by minus 2 is 2. So now I know that the b there is minus 2. So let me go back to this, my original statement, and I can write down that b is 2 now. Right, next. Let's let x equal 2/3 now. The reason I've chosen 2/3 there is it's going to make this bit become 0 and this bit become 0. So it's going to allow me to work out the c term. So if I substitute 2/3 into the left-hand side there, I get 3 times 2/3 squared minus 4, which is minus 8 over 3. And like I said, the a term and the c term disappear. Sorry, the a term and the b term disappear, and I get c times 2/3 squared, which is 4 over 9. So, working out the c then, so I'm going to times both sides by 9, and I'll get minus 72 over 3. Then divide both sides by 4. Oops. I'll get minus 72 over 12, which is 6. So c is minus 6. Right, finally, we need to work out the a term. Now we're going to have to use a slightly different method for the a term because there's no substitution that I can put in here. There's no value of x that I can substitute in that's going to make this nice and simple. But like I say, I do know that b is 2 and c is minus 6. So what I'm going to do, I'm going to compare coefficients. I'm going to compare coefficients of x squared. So on the left-hand side, I've got 3x squared. Now, on the right-hand side, if I expanded this out, I'd have ax times 3x, which would give me a 3ax squared. The second term, there's no x squareds there, so I don't need to worry about that. And I do have a minus 6x squared there. So just focusing on the coefficients, the numbers in front of the x squareds, I'm now able to say that the 3a would have to equal 9, so that a is 3. And that is my answer to part A. So that's the partial fractions bit of this question. That's part A. We are then told that x is greater than 2/3, and we're told to find the general solution of this differential equation, giving our answer in the form y equals f of x. So we're going to separate the variables. The y stays on the left-hand side. So anything with y's need to move over to the left-hand side. So this y is going to be moved down to the denominator there. We're going to divide both sides by y. Anything with x's will move to the right-hand side. So the dx is going to move up to the top up here. We're going to times both sides by dx, and we're going to divide both sides by the x squared times 3x minus 2. So just focusing on the y terms first of all. Like I say, we've got the 1 over y dy. So that's gone down here. The 3x squared minus 4, that stays exactly where it is. This dx moves to the top there. We're multiplying both sides by dx, and we're dividing both sides by the x squared 3x minus 2. And then at this stage, you should hopefully notice that this is what we had in part A of the question. So actually we can just replace that with our answer from part A. Which is going to make this much easier to integrate, because that's going to be our next step. Right, the 1 over y, that's going to integrate easily to be ln y. The 3 over x is going to integrate to be 3 ln x. The 2 over x squared function, I need to rewrite that with a power. So I'm going to rewrite that as 2x to the power minus 2. I'm just going to move this up here, so it'll be 2x to the power minus 2, just to make it easier for me to integrate it. It will not integrate with a logarithm because it has that power. So we'll add 1 to the power and divide by the new power. So the 2 divided by the minus 1 will be minus 2. And then the third term, again, the denominator is linear, just like these two, so it will be a logarithm. There's no power on the bottom there, so it will be a logarithm. So I'd have minus 6 ln 3x minus 2, but by the reverse chain rule I need to divide by the derivative of the inside there. So I need to divide by 3. The 6 divided by 3 is 2. And not forgetting our plus c. Right, all I need to do now is rearrange it so it's in the form of y equals f of x. So to do that, I am going to take the exponential of both sides to make y the subject. So if I do e to the power on the left-hand side and e to the power of the right-hand side, on the left-hand side, the e and the ln cancel out and just leave me with the y. And on the right-hand side, I've got all of this. I've got e to the, and it's really important, all of this is in the power. We'll tidy it up in a minute. We'll get the 2. All of it must be in the power. Right, let's now create a bit of space because we can just tidy this up to get our final answer. Not sure why that's not working. We'll just carry on at the top. Right, so I'm going to split each of the terms up on the left-hand side. So I can rewrite this as e to the 3 ln x times e to the minus 2x to the power minus 1 times e to the minus 2 ln 3x minus 2 times e to the power c. Right, now in order to simplify this even further, I can move this 3 up to be a power here, so it'll be an x cubed. I'm not going to bother doing that with this term here because the e, there's nothing that's going to simplify there. The only reason I did that with the first term is so I've got e to the power ln, which will cancel out. No point doing that with the second term. The third term I'm going to take this minus 2 and put that up there to be a power, so that again I've got e to the power ln. And e to the power c, well that's just a constant, it's just a number, so I can call that a. So I've got that constant a. Like I said, the e to the power ln is going to cancel out, so I've just been left with the x cubed. And similarly, this term here, the e and the ln will cancel out, and I'll be left with the 3x minus 2 to the power minus 2. And then finally, that e to the power minus 2x to the power minus 1, that's not going to cancel out, so that'll stay there like that. And I think I could probably leave my answer like that. Or I could simplify it a little bit more with those negative powers. For example, I could write it like this. Just moving those negative powers so they're on the denominator of each fraction. I think that's probably as simple as you can write it. But you could have left your answer like at this stage here.